Welcome to Section 2 of Unit 7, where our focus will be on a concept called outliers and the influence they may have on our measures of central tendency. What is an outlier? Have a look at this picture. You see an adult duck, possibly the mother duck, with the ducklings. If I was to ask you, is there one of these ducks that stands out more than the other? I'm quite certain you would say, yes, that the adult duck certainly looks much bigger than the ducklings. This visual will help us in our understanding of what an outlier is, believe it or not. From a previous video, if you recall, the note was made to be careful using the mean if you have extreme values. This is where we're going to look at these extreme values. An outlier is a number in a data set that is significantly different from the other numbers. It will be noticeably less or noticeably greater compared to most of the numbers. It may result from an error in measurement or recording. And I'd like you to reflect here on the example that we did in a previous video on the heights of the members of the track team. And if you recall, there was a height that was 16 centimeters. The one that was slightly larger than your typical 15-centimeter ruler. It is very possible in that case there was an error in recording. Outliers, though, may be an important piece of information. If we look at our visual to the right again, the adult duck, who yes, could be considered an outlier, is a very important piece of information here. Those ducklings would be in trouble without the adult duck. And sometimes the outlier, in terms of whether or not we should include it, whether it should be part of our set of data, it may be a matter of choice. Let's consider a couple of examples. We're looking at this particular set of data, and our only task here right now is to identify any outliers. And it is important to note that we're not going to consider any context for the data here. The idea is to simply pick out the numbers that do not seem to fit. What these numbers actually represent, we're not going to worry about that right now. So if we look through this set of numbers, 48, 52, 58, 8, 60, 45, 120, 57, and 58. Are there any numbers here that just don't seem to fit with the rest? I contend that the 8 and the 120, these two data values are significantly different from the others. So the outliers are 8 and 120. 8 is significantly less than the others, 120 significantly more. How about this set of data? 4.2, 6.5, 10.4, 3.7, 8.8, 7.9, 5.6, and 9.9. If we look through this set, are there any values that look significantly different than the others? For instance, if I look at the smallest value there, 3 7/10, is that significantly different than all the other data values? And the answer is no, because 4.2 is not that far away from 3.7. And then 5.6 is not that far away from 4.2. Similarly, if we were to look at the largest data value in this set, 10 4/10, is that significantly different from all the other pieces of data? Once again, the answer is no, because 9.9 is pretty close to 10 4/10. And then 8.8 is pretty close to 9 9/10. Bottom line, there are no pieces of data here that are significantly different than the rest. Therefore, no outliers. If we consider this graphically, a picture sometimes is worth 1,000 words. For the given set of data and the trend it follows, outliers would appear to exist where? I'll give you a second to have a look. We would have an outlier at 1,7, an outlier at 2,8, and an outlier at 5, 1.5. These values, these points don't quite fit the trend. And now I'd like you to proceed to the activities for Lesson 1.